Hello, my name is Gabriel Smithbauer, and this is the Rotomolder Design and Development for Shot Put Shell Senior Project. My advisor was Professor Brad Johnson. My sponsor was the Penn State Barron Track and Field team. The team was looking for the best plastics processing method of molding indoor shot puts in-house. This project led to the development of a rotomolder machine design for molding men's shot puts. These shot puts must adhere to all NCAA and project specifications seen in Table 1. The two primary materials tested in this project were Paxon E55 HDPE and Shell 35 R5U LLDPE. Design Iteration 5 was the most successful design for molding shot puts. This iteration involved many of the machine design requirements for this project, which can be seen in the left column. A shot put molded with Iteration 5 can be seen in Figure 3 alongside the final design iteration. The important impact surfaces during drop impact testing were the parting line and plug. These features are not uniform with the rest of the shell and can be seen as an area concern in impact. Using thrower data from the world record throw by Ryan Krauser, a maximum drop height was determined of 6 meters to test the shot puts in a worst case scenario. Shot puts were dropped 14 to 16 times in a 30-minute interval to simulate being thrown in practice. Failure was characterized by the formation of a critical crack length that allowed for lead leakage. There was no crack formation, but the Shell 35 R5U shot puts were more susceptible to warpage in the shells. Molded shot puts were cut into 4 quadrants perpendicular to the parting line and 6 points marked on each quadrant to measure the percent difference in the thickest and thinnest regions. When all the powder was fully melted, Paxon E55 shot puts showed 40.98 to 51.14% variation, and Shell 35 R5U showed 61.66 to 149%. The difference in melt flow rate, or MFR, of the two materials is important to note. Paxon has an MFR of 0.43 grams per 10 minutes compared to 5.00 grams per 10 minutes for the shell material. Any imbalance in the rotomolder rotation would cause powder to melt and form in the top half of the shot put, which showed significant variation in wall thickness. Overall, Paxon E55 creates shot puts with more uniform wall thickness. The heat time was the most important processing parameter because the heat transfer kinetics of the molding cycle need time to occur. Air is heated in the oven using convection to the outer wall of the mold. The inner wall and material are heated up through conduction of the heat through the outer wall into the cavity of the mold. Paxon shot puts required higher melt temperatures and longer heat times to fully melt the plastic material. I would like to take this time to acknowledge Professor Brad Johnson for advising me during this project, Professors Jason Williams and Nick Vitelli for being project graders, Machinist Chris Bartlett for the machining of rotomolder components, Elwood Specialty Steel for their aluminum donation for the shot put mold, and then Shell and ExxonMobil for providing the material through donations so that this rotomolder could run material. Thank you.